Hello, Professor. My name is Lu Feng. Today I'm going to present my research, sentiment and behavior prediction from Amazon reviews using machine learning. First, I would like to thank my supervisor, Dr. Cao, for his guidance and support during my study. I hope my presentation will show how machine learning can help us better understand customer opinions. This study uses Amazon reviews from Kaggle to predict customer sentiment. I compare a dictionary method weather and 6 machine learning models, including logistic regression, Naive-Bayes, SVM, decision tree, random forest, and XGBoost. After cleaning the test and using TF-IDS, I used the SMART to fix class imbalance. That random forest works best for sentiment analysis. The keywords found by the models help businesses understand what customers care about. I also discuss some limits and suggest using deep learning and more features in the future. This slide shows the structure of my presentation. First, I will cover the background and objectives in the introduction. Next, I will explain my methodology, including data proposing and model building. Then, I will show the main findings, followed by discussion of their meaning and impact. Finally, I will wrap up with my conclusion and the future outlook. Now, let me start with some background for this study. E-commerce platforms like Amazon get huge amounts of user reviews every day. These reviews guide buying decisions and help sales improve customer experience. But reading and making sense of so much text by hand is so slow. It is also hard to build models that work well on every type of sentiment, especially when some classes are small or the language is unclear. About the objectives and the significance of this research. The goal of this study is to build and compare different models for sentiment analysis of Amazon reviews, including both lexicon-based and machine learning methods. This helps us find out which model works best for understanding customer opinions. Good sentiment analysis can help e-commerce companies quickly detect negative feedback, improve their service, and better meet customer needs through smarter, data-driven decisions. To do this research, I first got about 21,000 Amazon reviews from Kaggle. I only used the newest 5 years of data and took out anything missing, repeated, not in English, or incomplete. Next, I changed the star rating in 3 groups: positive, neutral, and negative. I cleaned up the review text by making all the words lowercase, taking out common words that do not add meaning, and using the monetization to make words simpler. Because some groups have fewer examples, I used the small to make the classes more balanced. In the last step, I used TF-IDS to turn the clean text into numbers so that the machine learning models could use it. To build and compare different models, I chose 6 machine learning models. Here I will focus on the 3 best ones: random forest, SVM, and Naive-Bayes. I snap the data into a training set, 75%, and a test set, 25%, to make the results fair. For every model, I used the 5-fold cross-validation to make sure the results are reliable. I used accuracy and macro FE score to measure how well the models did. Confusion matrices were also used to show which types of reviews were more difficult to predict. Random forest puts together many decision trees and takes the majority vote. SVM tries to draw the best line between different classes. Naive-Bayes predicts sentiment by counting word frequencies. Here we can see the performance of 6 models on sentiment classification. Random forest, Naive-Bayes, and Linear FBM performed the best. Random forest has the highest accuracy at 88.7%, and Naive-Bayes achieved the best macro FE score at 62.27%. In comparison, the Veda dictionary math only got 16% accuracy and 41% MQF1 score, showing that machine learning models have a clear advantage for this test. This confusion matrices shows the results for 3 types of sentiment. Random forest has the highest accuracy and the least mistakes, especially for negative and positive reviews, but all models, including random forest, still find it hard to get neutral reviews right. Linear SVM and NaviBase also struggle more with neutral sentiment. This is a common problem in text analysis. And future importance visualization shows the most important word for predicting review sentiment. For example, surveys, customer, and delivery appear often in both positive and negative reviews. Such visualizations help us understand what customers care about most and give businesses clear ideas on where to improve and what issues customers talk about the most. The results show that advanced machine learning models like random forest and NaviBase perform much better than dictionary-based methods in analyzing sentiment from Amazon reviews. This proves the value of using advanced models for complex text data. However, all models, including the best ones, still have trouble with neutral sentiment, mostly because of class imbalance and unclear language. This means future work should use more advanced features and deeper models. To sum up, ensemble machine learning models, especially random forest, gave the best results for sentiment classification, with higher macro F1 score and accuracy than traditional or less complex methods. These findings can help e-commerce companies automatically track customer satisfaction, find negative feedback faster, and optimize their service based on what customers really care about. In the future, using deep learning and richer behavioral features can make sentiment analysis even more powerful and useful for real business needs. Okay, that's all my presentation for thesis, and thank you very much for your time and attention.